Hey everyone, and welcome! I've spent years working with electronics, and today I want to let you in on a little secret. It's a kind of magic trick that's happening inside almost every single gadget you own right now. It's the real reason your phone battery can last all day, and we're about to pull back the curtain and see exactly how it works. So, to get us started, just imagine this for a second. You've got a big, powerful 12-volt car battery, super strong. But what you want to power is this tiny, delicate 3-volt light. Now, if you just connect them straight together, what happens? Poof. Yep, that little light would be toast in an instant. So, how in the world do we safely take that big voltage and shrink it down for our little light? Well, that's the puzzle we're going to solve together today. There's a couple of ways you could tackle this. The simple way is to use something called a resistor. But honestly, it's really wasteful. All it does is take that extra energy and burn it off as heat. I want you to think of it like a leaky garden hose. Sure, some water gets to the flower, but a whole lot of it just spills out and makes a puddle. It's a waste. But there's a much smarter way, and that's called a buck converter. So, what's the big secret behind this buck converter? What makes it so special? Well, the main idea is actually incredibly simple. Instead of just burning off that extra power, what if we just turned the power on and off? I mean, really fast. We're talking hundreds of thousands, maybe even millions of times every single second. And this idea of super fast switching brings us to a really important term. It's called duty cycle. Now, that might sound super technical, but I promise it's easy. All it means is the percentage of time that our switch is on. That's it. Think of it like a dimmer switch for a light. If you turn the knob halfway, that's like a 50% duty cycle. If you turn it just a quarter of the way, that's a 25% duty cycle. Simple, right? Okay, so let's try it. If we take our big 12-volt supply and we flick that switch so it's on for exactly half the time, that's a 50% duty cycle, what do you think the average voltage is going to be? You got it. It's 6 volts. We literally just cut the voltage in half, just by flipping a switch really fast. All right, but hold on a second. We've hit a little snag. We lowered the average voltage, sure, but now our power is all blinky and choppy. It's like a strobe light. Your phone or your game console, they wouldn't be very happy with blinking power, would they? No way. They need a nice, smooth, steady supply of power. So, how do we smooth it all out? To fix our choppy power problem, we need to call in a couple of my favorite electronic superheroes. I like to call them the smoothing crew. These two components are absolute masters at taking messy, bumpy electricity and making it perfectly smooth. First up, meet the inductor. This component's whole job in life is to keep the flow of electricity, the current, from changing all of a sudden. The best way to picture it is like a big, heavy merry-go-round or a flywheel. You know how it takes a big push to get it started, but once it's spinning, it really wants to keep spinning. It fights against any change. That's our inductor. And the second member of our amazing crew is the capacitor. Now, if the inductor smooths out the flow, the capacitor's job is to smooth out the electrical pressure, or the voltage. And it does this by acting like a tiny, super fast recharging battery. It basically stores up a little bit of energy, and the moment it sees a dip or a gap in power, bam, it releases that energy to fill it in. Okay, so here's how they work together as a team. When our super fast switch flicks on, power rushes in. The inductor starts storing up energy in a magnetic field, and at the same time, the capacitor fills up with energy, kind of like a bucket filling with water. Then, when the switch flicks off, the battery's out of the picture for a split second. But does the power stop? Nope. The smoothing crew jumps into action. The inductor and the capacitor release all that energy they just stored, keeping the power flowing to our light bulb without any interruption. And just like that, by doing this over and over, millions of times a second, the team works its magic. They take that choppy, messy, blinking power from our switch, and they transform it into this beautiful, smooth, steady, and lower voltage. It's exactly what all our electronics need to work perfectly. It's incredible teamwork. So, if there's one thing you remember from all this, it's this. It all boils down to a super simple, almost magical formula. The final voltage you get out is just the duty cycle times the voltage you started with. That's it. That's the secret recipe of the buck converter. So let's circle all the way back to our first problem. Remember, we had 12 volts coming in, but we only wanted 3 volts for our little light. So using our magic recipe, what duty cycle do we need? Well, 3 is a quarter of 12, right? So we need a duty cycle of 25%. We just tell our switch to be on for just a quarter of the time. And check the math. 0.25 times 12 volts gives us exactly 3 volts. Problem solved.
Okay, so this is a really cool trick. I get it. But why does it matter so much? Why am I so excited about it? Well, it's because this amazing shrinking voltage machine isn't just some neat science experiment. It is, without a doubt, one of the most important circuits in our modern world. It is a true unsung hero, and it's hiding everywhere, in plain sight.
I mean it, literally everywhere. The smartphone in your pocket, it's got a bunch of buck converters inside. Your laptop, same thing. Your game console, the little white block you plug your phone into, even giant electric cars. Pretty much any gadget that runs on a battery is using these clever little circuits to efficiently create all the different tiny voltages it needs to make everything work. And that is the real magic. Because buck converters are so incredibly efficient, we're talking over 90% efficient. They don't waste power as heat like that old leaky resistor hose we talked about. And what does that mean for you? It means the batteries in our favorite gadgets can last for a long, long time. It lets us play our games, do our work, and talk to our friends for hours and hours. So that's the story of the amazing buck converter. I seriously had so much fun exploring this with you today. Hey, if you thought this was cool and you want to learn about more of the secret tech that powers our world, please do me a favor. Hit that like button, click subscribe, and maybe even share this with someone you think would get a kick out of it. It helps out a ton, and I really appreciate it. I'll leave you with one last question to think about. The buck converter. It's just one piece of the invisible magic all around us. What other hidden technology do you wonder about? Drop a comment below and let me know. Always keep asking questions and never ever stop exploring. Thanks again for hanging out with me, everyone. I'll see you next time.